Alright, so we're working with triangles again, and our goal is to find this angle. And so it's going to take a little more thinking to try to figure this out. So, I'm here to help you think with me. These tick marks tell me that it's isosceles. And if the sides are the same, then the two angles that are opposite of them are also the same. So both of these angles down here are 75. Man, I always have a hard time for this focusing at the beginning. Let's see if we get this camera to focus. No? Not going to focus? Alright, and here's a triangle property for you. I'm going to add 75 and 75. I'm sure as I work. Maybe it'll focus in as I work here. I get 150. And this angle and the two angles away from it are always equal to each other. And you have your answer. There we go. Just took some time. Alright, here we go again. Here we have an equal angular triangle. So these two angles beside each other add up to 180. So I can subtract 180. And the angle right here beside is 60. Because all three sides are the same size, all three angles are the same. So that means x must be 60. Number 27. Again, this is called isosceles when two sides are the same. So if that's 45 degrees, the angles also match, like the sides match. And then I want to find the missing angle up here. So I'm going to add them together, plus x, and I know that equals 180, so that when I subtract, I get my answer. So that missing angle up there is 90 degrees. Alright, I want to find this angle here. Again, this is isosceles. So these two angles, I'm going to call them y, are the same. So if I add those two angles and 102, if I add that together, it's going to equal 180. So I'm going to subtract 102. That gives me 98. And then divide by 2 gives me 49. And then if that's 49, right beside it, I can go 180 subtract 49, and that will give me the answer I'm looking for. So the measure of angle x is 131 degrees. All right, 29. Again, it's isosceles. So whatever angle in terms of it, they're the same size. So if they're the same size, that means x must equal 8 for it to be match. Just like this, right? This is going to be, all of these are going to have this kind of feel to it. All right, so these angles are the same size. So if they're opposite of each other, they're the same size. That means x must equal 5. Here, all three angles are the same size, which means all three sides are the same if all three angles are the same. So if one side is 6, all of them are. So this missing side is 6. Again, all three angles are the same, which means all three sides are the same length. So if one side is 7, they're all 7. So the missing side there is 7. All right, turn the page. Now we're going to do a little bit of algebra with it. This is an isosceles triangle. Two angles are the same. So the sides opposite of them are equal. So x plus 13 is equal to 7. And I'm going to solve for x. So I'm going to subtract 13. So x equals negative 6. Again, an isosceles, which makes these two sides equal to each other. And then I'm going to solve it. So instead of positive 23, and if you need to, you can use a calculator. 7 subtract 23, that's negative 16. Divide by 2, and the answer is negative 8. Number 35. Again, isosceles, so these are equal to each other. Subtract 10, so x is equal to negative 6. Again, isosceles, so they're equal to each other. Add 9, divide by 2, and you get your answer. Next, can you classify these triangles by its angles and its sides and base your decision on the actual lengths and sides of the measurements? So I'm going to see how one angle is larger than 180 right here? So this is an obtuse triangle, and all three sides are a different length. So because of that, it's also called a scalene. Here, as far as I can tell, maybe I should measure it. I don't know. What is this? That looks like that. And does that look like almost one this way? Yeah. Does that look like it this way? Like an actual measurement of it? I think so. I'm going to say that all the angles are the same and all the sides are the same. So we can call this equal angular, and we can call it equal lateral. Both of those are names when the sides are the same and with the angles are the same. Those are names for triangles. All right. All these angles are smaller than 180 or smaller than 90. So we call that an acute triangle when all the angles are smaller than 90 and all the sides are a different length. So I'm going to call that scalene. I don't think two sides are the same there. Here we have one angle that's bigger than 90, and again, all three sides are a different length, so it's scalene. Now, if two sides were the same, we would call it isosceles. So here we actually have numbers, so I like that a lot better than the other one. So let's look at the actual numbers. So two sides are the same, so we call that isosceles. Fancy word, right? A Greek mathematician. And all the angles are smaller than 90. So we call that an acute. So this is an acute isosceles triangle. Here, all the angles are smaller than 90. That's what it means for it to be acute. And none of the sides are the same. So that's called scalene. I know, you've seen these words before. It's just been a while. Here, all the sides and all the angles are the same. So like we did on the other page, this is equal angular and equal lateral. If I can spell it. So equal angular and equal lateral are the words that we use. I don't know if it's an I. Let me see how to spell equilateral. Am I spelling it right? I know. Let's see. No, it is spelled that way. I thought it was, but that, equal is spelled E-Q-U-A-L. But that's how you spell it. So equal angular and equal lateral, that is how you spell it. So my gut was right, even though when I saw that word, it didn't feel right. But it is. I typed it in Google. It's got to be right. Same thing here, right? All the angles, all the sides are the same. So let's make sure my gut knows how to spell it. That's equal angular and equal lateral. So one has to do with all the angles being the same, and this is being all the sides are the same. All right, last questions here. Can you classify them in terms of what you see? So here again, by the diagram markings, all three sides are the same and all three angles are the same. So this again is equal angular and equal lateral. Those are the two names for the triangles. Here, we have a 90-degree triangle. So 90 means it's a right triangle and two sides are the same. So we call that an isosceles. So the angle makes it a right triangle, and two sides being the same makes it isosceles. Here, we have an obtuse angle, and two sides are the same, and we call that isosceles. when two sides are the same length. Here, no markings at all. So I can tell that that angle is bigger than 90, so that's obtuse. And none of the sides are the same length, so we call that scalene. And that's it. You did it. Mr. G Math over and out. I'm proud of you for doing work with triangles with me. I hope that was a review. And then we're going to get into some good stuff like trigonometry soon, things like that. All right. Until next time.